Here's a panorama from the middle of Granite Springs Valley. So off to our east is the Trinity Range. If you look at it closely, you'll see that there are layers of Miocene volcanic rocks that have slightly different dips here and there. There's various normal faults cutting that up. Off to the north, the snowy mountain that's not super far away is on the other side of the playa. There is the Seven Troughs Range, which is also underlain by Cretaceous granites, at least in the northern part. Rotating around this way, we can now start to see the northern Sahwave Range. And so the northern Sahwave Range is going to be composed of actually you can see, so right where this road is heading, you can see a gap in the mountains. That's Juniper Pass, where the granite diorite of Juniper Pass is named for. So that's basically you can see actually the northern margin of the batholith here. The mountains behind that are the Blue Wing Mountains, which are made of the Jurassic and Triassic jungo terrain. And then that's intruded by the granite diorite of Juniper Pass up there near the pass. And then as we come down here, the high part of the Juniper Mountain and the higher parts of the Sahwave Range are made of the granite diorite of Bob Spring. And then when we come down to the central part of the Sahwave Range, you can see that there's this area with a lot of big, bold outcrops of granite diorite, and the mountains are a little bit higher, and it sort of dips off to either side. So that sort of dome in the middle here is the Sahwave granite diorite, which just has a slightly more resistant outcrop than the granite diorite of Bob Spring. And then we get back into on the southern part of the Sahwave Range there. You can see there's a low relief surface, and that gets back into the granite diorite of Bob Spring and eventually the granite diorite of Juniper Pass on the southern side. And so all in all, this spans 30 or 40 kilometers north to south. Another thing you can see from here, if you squint at least, is that first of all the range front here is very straight, and in places you can also see that there are some scarps, relatively recent topographic scarps cutting along the range front. And so there is an active, or at least very recently active, normal fault. I'm going to call it an active fault. It hasn't ruptured in human history, but there are definitely fault scarps, normal fault scarps that cut the Quaternary alluvium in many places, almost continuously along the range front. So they're actively being uplifted and tilted away from us, which is corroborated by the tilt of the Miocene volcanic rocks and sediments that are dipping away from us on the other side.